Let's get rolling. So last time, let's see. Oh, by the way, how was the hackathon this weekend? Improvement?
My group was really good. I like mine.
So was it an improved experience from last time? Okay.
Slightly better.
Only slightly, or are you being okay?
I got to do something.
Well, that seems like it's a lot better. That's the key distinction. Well, that's a step in the right direction. Okay. So for our homework, well, shouldn't have taken tons of time, just having you put a couple of things together. You were to, I'd given you last time, I'd shown you how to spawn a dude or whatever. And I know some of you were still going through like the debugging process of figuring out how to, we were working with an error this weekend for pushing stuff to GitHub and all that stuff. So these are all good learning experiences. I know it's kind of frustrating, but once you've figured out all the crap that doesn't work, you'll start figuring out the stuff that does work. And like, for instance, I've used Unity for years, but we were sitting there messing with Hunter's thing for hours until we finally figured out that he was just over some quota. He had uploaded probably something without git ignore on Unity. So he just blew right past his gigabyte of, so, but you know, by just messing with the stuff, I know it can be frustrating. You are learning things. So try to appreciate that, that fact. All right, so I already rewrote some stuff in here. Well, I just added a couple of things. So what we had in here before, I just wanted to make sure we got through some stuff today. So I just kind of pre-did this. What we had in here before is I had you initializing instantiating a single enemy or whatever. And then I also showed you how to generate some random numbers, right? So what I went ahead and did is I just expanded my for loop to do something 100 times instead of 10 times. So we have a whole bunch of enemies. All right. Now, hopefully you noticed that when you instantiate, the instantiate function, so if I start typing instantiate here, the instantiate function, let's see, is it gonna, it returns a transform. Where's my for overloads? Are you going to show me the overloads? Let's just look at it in the web. Unity instantiate. I think the default one returns a transform. I wonder what type T is on here. Well, in any case, what this guy does is after he instantiates our enemy prefab at our particular spawn point, that was just an empty object we had on there, and with no rotation, that's what this quaternion identity thing is. Quaternions are how we figure out, that's a weird mathy thing that you don't want to do by hand, and Unity does it for you. But identity means nothing, 0, 0, 0, 0. Once we instantiate this guy, he'll be in the scene. He does come into existence. But if we want to be able to programmatically do stuff to him, we need to capture the guy that was just added. So I'm going to take the return value of this guy and I'm going to throw it into a transform. Now, we had already previously talked that transform in Unity is sort of kind of like object is in Java. It's kind of our lowest common denominator of stuff we can hold. All right. So We happen to know that when we create an enemy prefab, what we're actually going to end up with there is a game object that has a bunch of components hanging off of it, right? Because our enemy prefab here, this guy, he's got box colliders, a rigid body, he's got a script associated with it, yada, yada, yada. Okay. So that's what we're going to get after we instantiate that guy. So then I'm going to go ahead and I'm going to extract the rigid body from that transform. We've done that before. And then I'm going to give some velocity to that rigid body. All right. So what I did is I used my random number generator and I decided, okay, well, I'm not going to have it go on the y-axis. So, we're not going to have it fly up in the air. You could have if you wanted to. But for the X and the Z, I just had it give a value between 10 and 30. Because the velocity is a vector 3, some amount of power in X, Y, and Z directions. Okay. So random number between 10 and 30, nothing. Random number between 10 and 30. So we're going to do this 100 times. So we should have 100 enemies spawn and kind of bouncing around in some different directions. All right, so let's go and look at that. All right. So there's our 100 enemies like that. Some of you maybe went ahead and updated the box script so the enemies kept moving in a certain direction or something like that. That was fine. I just effectively dropped them out of the sky and shoved them and just let it do what it's going to do. It has kind of a cool look, doesn't it? Isn't that kind of cool how much Unity just does for you? Okay, so really to complete the homework, that would have done it. Something along those lines. I see the hate, the hate in some of your eyes. But the hope is that some of you did it in some really interesting ways. That's kind of a cool thing with Unity, and many of you maybe did it in better ways. Like I had said, last time I did much with Unity was definitely in the 2019 version, so I'm a whole version out. So some of you have probably worked with Unity more recently than I have. Kind of the point in this class where, hey, we're using C#, we're applying it to something we haven't used tons, and we're seeing that, hey, we already have some skills based on something we've learned the last semester and a half. Go ahead. Position, rotation, and size. This guy. Well, this instantiates it. This stores what was just instantiated in a variable. Yep. So this was my spawn point. Is it the drop down thing here? Who taught me how to, Danny, you taught me how to get the thing back, didn't you? The twisty XYZ thing up here. Oh, that makes a whole lot of sense. There we go. Nailed it. All right, so yeah, right now this is my spawn point. So I think it used to be here. I kind of moved it down and over. So it's just an empty game object. So that's spawn point. And here's kind of the punchline. An empty game object, all that guy is a transform. So at the very least, we know for a fact that instantiate will produce something that at least has a transform. We happen to know, since we're instantiating something that we built, this enemy prefab, that it's got a little bit more meat to it than that. So yeah, this guy brings it into the game at this location with this rotation. This part right here catches the thing that came out because I want to do some extra stuff to it. Because if I don't do that, I've now lost my opportunity to get it. Because now it's out in the wild, it's doing its thing. And I mean, I probably can figure out one way or another. I can maybe start trying to grab the current scene and have it search through to try to find some of these instances of maybe prefabs, but probably missed my opportunity if I want to mess with it. So I'm going to catch the thing. This extracts the rigid body from it, since I know it has a rigid body, because when we built that enemy prefab, we put a rigid body in there, and then I'll apply some velocity to that rigid body, which is going to be this vector 3 with a random X and a random Z and a Y of 0. And if you want to put a random Y, might kind of have a cool look, because some of them are going to pop up in the air, but then they'll fall back down since gravity's pushing against them. So it actually might look kind of cool. And I saw your hand. Well, actually, go ahead. Who doesn't have a rigid body? Core. Well, core is our singleton. So my code that I'm in here is our start function inside of core. So you're saying you couldn't get this, you had an error here? Like I said, I hadn't heard of it. Okay. Okay, so my guess is this. Instead of, so when we instantiated here, we got a new version of our enemy prefab. That guy does have a rigid body. My guess is, so we called that variable T right here of type transform. If you did something like this dot game object like that, now you're talking about the game object associated with core, which, like you're saying, does not have a rigid body. So then you get an error, because now this game object right here is different than the transform that was born when we instantiated an enemy prefab. Enemy prefabs have rigid bodies. Core didn't, because we didn't put one in there. Yeah. So yeah, you would get errors then if you tried to extract a component that wasn't part of it. All right, let's see what this guy looks like when we, this could actually look kind of cool. Some of them should kind of fly up in the air a little bit. Well, oh, they all flew up in the air because I did a random number for all of them. So actually, if I want to have it a little bit, we'll tone it down a little bit, but we'll let it be as low as 0. That way, some of them will just fall immediately. Oh, yeah. All right, obviously that's better. All right, other questions? Okay, so what I want to do next, at some point pretty soon, we're going to start looking at the, by the way, I removed the roofs from the, because it was kind of hard to navigate, but then I decided we're going to do this not a little differently, but differently for the moment. I want to start doing something with the asset store, bringing in like an actual cave instead of our stupid houses. I don't know, you guys have been messing with some assets. Has the store been like stupid slow for you? Oh, then there's something going on today. Like it's not loading. It's not loading well, but that's okay. Because what I want to do is I want to show you some artificial intelligence stuff built into this. All right, so if you will allow me, I'm going to go into map. Will it let me just turn the whole map off? Oh, hold on. Give me a moment. Earlier, I put my floor into map, which will be a problem for this. I'd like to keep the floor. All right, so I just disabled all my rooms. They're still there. They're just turned off for a second. All right, so now what I want to do, ultimately, what I'm going to try to accomplish here is I want to have my player and then I want to have my enemy. I want to put some stuff in between my player and my enemy so it's hard for the enemy to get to me. And then I'm going to tell the enemy to try to get to me. Okay. So let's start with that. So we'll zoom out. Here's my enemy. All right. Enemy has a box script. Let's go ahead and make the box script aware of the player. So we'll add a public game object so we can drag the player into that thing. So the enemy knows who he's going to chase is what we're trying to do. Okay. So we'll go into our box script. This guy right here. What's our box? Oh, that we have our collision crap in there. All right. So we're going to make a public game object. Call this guy the player. And by doing that, now we'll have something where we can drag, this is MVC, right? We can drag our player object into that box script. So now we have the player object here. So I'll go ahead and take our player and I'm going to drag him over there. All right. So now this particular enemy with this particular box script knows about that particular player. All right. Now, let me look up something here real quick. Unity game object. Well, let's just look at game object. I think I can tell it to move towards something else. I want to show it the bad way first. Public methods. Okay, I cannot do that yet. Okay, well, I can certainly tell it to start moving in that direction with some velocity, right? So let's go ahead and do that. So right now, the box script knows where the player is and it'll track that player. So what I'm going to go ahead and do is inside of update, we're going to put some velocity on the this game object, the enemy. We're going to put some velocity in the direction towards wherever the player currently is. That way, when the player moves, the guy will keep pivoting and zipping around and all that stuff. All right, let me go ahead and give myself a couple of, let's just do private transform. Actually, we actually don't even need that. We'll say vector3 player position. So then inside start here, we'll say player position is equal to, well, actually, I don't want to do it then. I want to do it every frame because the player presumably is moving. All right, but I also want to get my rigid body. Let's call this guy RB again. So we'll go ahead and set RB equal to this dot game object dot get component rigid body. All right, so now we have the rigid body that we can apply velocity to. So every frame, what we want to do is we want to say, what do I call it, player position is equal to the player dot transform dot position. So that's his vector3 position. That's where he is physically on the screen. Okay, remember, the transform holds 3 pieces of information: the where he is on the screen, XYZ, the scale, XYZ, and then the rotation, XYZ. I only care where the player physically is right now. So then we're going to go ahead and we're going to say, the rigid body dot velocity is equal to a new vector 3. And we're going to have it go in the direction of the player. So we'll start off with that. So this is going to be player position dot x dot y dot z. All right, so now it'll go in that direction, but with no real oomph. All right, so we have to give it a little oomph to go in that direction. So what I'll do is I'll go ahead and we'll give ourselves a public float called speed, and we'll start off equal to 20 float. So then down here, I'll multiply each of these guys by speed. That spacing is going to bother me. You don't need to put spaces, but. All right, so now anything with this box script on it, assuming it has a rigid body, will set its velocity at a default speed of 20 going towards the X, Y, and Z of wherever the player currently is on a frame by frame basis. Okay. Is it making it here? Let's click on the enemy. He is not making it here. Oh, we need to have his X, but now we have his Y going by some strength. We turn his Y off. So I think he's below the map. Which way is he going? He's going away from me. Because this is compounding. We take the speed off of it initially, or I'll just slow it way down. Yeah, he's going super fast still. Turn that off. All right, so there's that enemy. Let me move him so he's in my sight again. Okay. Oh, I'm multiplying each X, Y, and Z. I need to multiply the entire vector 3. So here's the vector 3 times the speed. And really, this should be able to stay position Y, because the player's position could change on the Y. It's not changing on the Y, but it could change on the Y. Zip past me. It changes speed to a 1. Where'd he go? Oh, well, I'm gonna play with that some more later. I'm probably just, well, my players. Oh, I see what you're saying. Oh, because I'm multiplying it. So you think it just shot up in the air? Yeah. So I would have been better leaving that at a 0 for the Y. This could be a last chance because this isn't actually what I want to show you. I'm going to show you some AI stuff and probably just do something stupid here. I think it's 20. Oh. Oh no, its speed is 1. Ah, let's not worry about it. All right. So effectively what I was trying to do is I was trying to shove my enemy towards wherever the player currently was. Whatever, I'm probably just doing something stupid. But if we want to use the built-in artificial intelligence with Unity, we have to use something called NavMeshes and NavMeshAgents. All right, so for starters, what I'm going to do is I'm going to add to this enemy a new component, and we're going to make him a NavMeshAgent. All right, now NavMeshAgents know how to do some extra stuff. All right, they'll allow us to accomplish what I was just trying to accomplish in an easier way, presumably. So if I out here and I do Unity NavMeshAgent, we'll see that things that are NavMeshAgents see. Acceleration. Set destination. So we can set a destination for a NavMesh object to a target. And let's see. Can we do that on a vector 3? I guess let's find out. So back here in our box script, we're now going to go ahead and have the NavMesh agent. Let's see, where's this guy live? UnityEngine.ai is where NavMeshAgent lives. We'll call this guy agent. Then inside of start, we'll set agent equal to this dot game object dot get component NavMeshAgent. So just extract another component from that guy. Good. It's an Apple event integration.
Yeah.
It's on a Mac.
Yeah.
I don't know off the top of my head. I'd Google it, maybe restart it real quick. Just restart Unity. Is it, did you restart your computer? Maybe do that. It sounds like maybe there's something going on with like the current OS. Like it might not even be a Unity coding bug. It might be just something like the Mac OS is acting up. Okay, so we have our agent. So now we want to set our agents every single frame. We want to update our agent's destination. Go back to our code here. So we'll say agent.set destination. Okay, this guy goes to a vector 3 target. So we can use our, what do we call it, player position. Oh, it's player position. So every frame will tell our agent to set his destination to the player's position. So we should constantly be trying to maneuver to update him. He might look a little sketch while he's doing this. Is he not moving towards me? Maybe I need to set his velocity to something. Maybe by default, his velocity is a 0. Maximum movement speed while when following a path. Let's set his speed. Why aren't you going anywhere? This enemy still has our player attached to its box script. Yes. We can set his destination, but I think that's different than set destination. Well, maybe set destination does just that. All right, well, let's make sure he'll do this. This will tell us if we have the stuff happening at least, right? Oh, wait a minute. We were never updating the player position. The player dot, let's see, the player position. Oh, I'm just gonna put it in there directly. The player dot transform dot position. We had an empty variable. It wasn't going anywhere. Well, now it's going somewhere. Well, now it knows what that is. So let me. Wait, where did I type that last thing? Oh, it's in here. Copy this real quick. We're going to say agent dot warp to that guy. Let's see if we're getting our player's position. This should just put them there at the same place. Okay, so we're definitely getting the player's position. He moved there. Oh, you know what? I didn't make my nav mesh. Mondays. All right. The second part of what we need to do here after we make our nav mesh agent, as you might imagine, nav mesh agents navigate nav meshes. We need to make a nav mesh. So, of course, I did that on purpose so you would see what would happen. He had no way to go. He had no way to get there. All right, so we'll make him not warp anymore. I'm also interested to see what happens with the default speed. So what we're going to do now, ultimately, what we're going to do is we're going to put some stuff in his way. But for right now, we're not going to put anything in his way. All right. But what we have to do here is we're going to take the floor. So I have the floor highlighted right now. So effectively, we need to give him his boundaries of where he's allowed to go. So I have the floor highlighted, and then under window AI navigation, we get this thing. Make sure you have navigation static clicked. And what you do is you highlight anything over here that you want to be part of that nav mesh. Right now, we only have one thing, the floor. All right. So once, and we say the navigation area is walkable. Then you click on this tab that says bake. And bake lets you choose the radius and height of your nav mesh agent. We'll just leave it default. Go ahead and click bake. And this should create a mesh for our nav mesh agent to then go and traverse. So it's cooking down here. This is pretty simple geometry. It shouldn't take that long, although my floor is fairly large. In fact, just for a minute, I'm going to shrink the floor down to like 100. So make it even smaller. All right. That should be palatable. So we'll go ahead and bake this guy again. Okay, it happened quick. So you see how it has like some weird lines and stuff on it now? It's been baked. It's out of the oven. All right. So now let me just confirm that I do have the set destination in here. Set destination to player's transform position. All right, so he's after me. Okay. So far, so good. All right. Well, now what we're gonna do is we're gonna go ahead.
I got some data when I went to do the NavMesh. It's like a great. Oh, there was some scripts I found there that they make it then actually.
That means
Every time I find one, it changes my private variable of NavMesh to engine that AI that NavMesh. I can take away.
okay. Well, my guess is down here you're gonna have some red errors. Okay. All right. Well, I can look at it after class. I just want to get you to the last part here. So what we want to do homework, and I'll push this. In fact, let me do that now before I forget. That. Oh, that's actually not the right one. This is the right one. Push. All right. So given the same repo. Now, a couple people had asked if you want to use mine as a starting point and then make changes to it with the expectation you're going to be able to push it up to you need to make sure you do what's called forking it first up in GitHub. You click the fork thing, which then makes a copy of it in your repository. You can always go and delete it. There's a way to pull an updated thing too. The other thing you can do, which is kind of a hack, is you can download my folder as a zip, unzip it, delete the hidden .git folders, create your own new repo, drag the folder in there, and now you own the code. It's the as a thing. But bottom line is, if you download somebody else's GitHub repo, they own it. You have the access to the code, but you don't have permission to push it back up to their repository, which is what the .git folder in there thinks you want to do, because you're not the one who created the repository. That makes sense? All right, so given this guy, add some rigid bodies on the map between the player and the enemy and rebake the nav mesh so that the enemy has a harder time getting to the player. Don't forget to mark all of your new rigid bodies as part of what should be considered for the nav mesh. Remember, the very first thing we did is we selected floor, and then we went into the navigation menu and made it hit the navigate whatever. What's it called? We clicked on floor here, went to the navigation thing. Under object, we clicked navigation static. You're going to have to do that for all the objects. You can select multiple objects and make sure all of them are marked to be taken in consideration before you hit bake. Make sense? So submit a link. GitHub and the self-assessment. Ultimate goal here is same thing we have now, but make it harder for the enemy to get to you. He's gonna have to go around stuff, and then you can trick him, and they'll have to turn around, and you're gonna see the AI make him map around different things. All right. Questions, comments, concerns, bribes. All right. I'll see everybody on Wednesday. And if you do have any specific feedback you want to give me related to the hackathon, feel free to send me a Slack message. Even if it's bad feedback, I want to hear it so we can keep making them better. Let me stop the recording real quick just so I don't forget. Oy, oy, oy.